So hello, good day. So today we are looking at this question. The question says a swimming pool is 12 meter long, 6 meter wide, 1 meter deep at the shallow end and 3 meter deep at the deep end. Water is being pumped into the pool at 1/4 meter cube per minute, and there is 1 meter of water at the deep end. Okay, so what percent of the pool is filled? That's the first question. And the second question is, at what rate is the water level rising? Okay, so this is the pool. So as we can see, this is the pool. Okay, the width, then the height at the deep end. This is the deep end, and this is the shallow end. Okay, and if you look at this, so this is the water level. It has risen up to 1 meter. Okay, it has risen up to 1 meter here. So we want to get the volume of this water, the volume of the water inside the swimming pool. Then with respect to the volume of the entire swimming pool, that is how we determine the percent of the pool that is filled. Okay, so percentage of filled water is going to be the volume of water over volume of the pool. Now, what is the volume of the water? You see, if this particular shape that is formed here is a triangular prism. And how do we get the volume? The volume is the cross-sectional area times the height. So this is the cross-sectional point area. Cross-sectional area, the same cross-sectional area that you will find on this side. Okay? So that same cross-sectional area, a triangle is formed here. Okay? So that triangle, we need to find the area and multiply it by the height. Right? So that's how we get the volume. Right? Cross-sectional area times height. So volume of the water is cross-sectional area times height. So the height this time around is this 6 meter. Okay? So this is now going to be, what is now the cross-sectional area? If we look at this very well, we'll see that this length from here to here is not given. And if it is not given, we have to find a way to find it. Okay? But if you look at this shape very well, if I bring it out here, let's just bring that trapezium. It's a trapezium. Right? This shape here, the side of the pool is a trapezium. And for a trapezium, okay, and this side, this is 1 meter. If we trace these points from here to here, so you know this is 12 meter, right? And then from here to here is 3 meter, based on the question. Okay, so if we use similar triangle, you can see that two triangles are formed here. One triangle here, then another triangle here, and the two triangles, they are similar. They are similar triangle. They have the same angle here, they have the same angle here, and then they have the same angle here. So they are similar in every respect. And when they are similar in every respect, then this side will also correspond to this side. If we label this side as x, it means x all over this particular side. They have the same correspondence. Okay, then we say x all over this. This is also 1. This side also 1 over this side, the side for this one. Okay, now the side for this one is what? You know, we are told that this is 1 meter, right? And the entire length is 3 meter. So if this is 1 meter, this is 1 meter. It means from here to here is also 1 meter, right? So which means this particular length from here to here is 2 meter. So this is going to be 2. Okay? So if we do cross multiplication, x will become 12 all over 2, and that will be what? 6 meter. So that is how we determine x. So we get x to be 6 meter. So now that we know x to be 6 meter, we can now find the area of this triangle, which is area of this triangle here. And what is that area? The area of the triangle is what? Half base times height. Right? So that will be half the base times height, then times the depth. Right? So the depth. So this is supposed to be called depth. Okay? Because we want to get the volume there, right? Okay, so half the base is what? The base is 1 meter. The height is what? X, which is what? 6 meter. Then times the depth. This depth, 6 meter. So that will be what? 3 times 6, that will be 18 meter. Okay, that is for that one, volume of the water. So this is how we determine the volume of the water. Now the volume of the pool. So volume of the pool is what? Is the cross-sectional area of the pool. You know, this is the cross-sectional area. It has the same area as the other side there. The other hand. So that's a cross-sectional area. And which is also the area of this trapezium. Right? So that would be what? Area of trapezium times depth, right? So the depth, let's call this one the depth, right? Okay, so this is now area of trapezium is what? Half a plus b times height, right? Half a plus b times height, then times the depth. So let's call the depth d. So let's call this side d. Then let's call this one a. This side here a. This is a. From here to here is b. Then the height h. Let's call this one 12 meter. That is a plus b. That is the two parallel sides of a trapezium. A plus b times the height. That will give us the area of the trapezium. Then times the depth. Right? The depth is 6 meter. Okay? That will give us the volume. So that is half. A is what? 1 meter plus b is 3 meter. Then times the height, which is 12. Then times the depth, that's 6. So if we multiply everything, so this is 4, right? So this is 6. 2 here, 6. 6 times 6 is 36. 36 times 4, that's what? This is 1 plus 3, that is 4, right? So 36 times 4, that's what? So that's going to be the volume. So this is going to be 144. So 144 meter cube. Okay. For this one is meter cube. Not meter, it's meter cube. Sorry. Meter cube. Okay. Now that we have this and this, we'll now use this particular formula to determine the percentage. So the percentage of filled water is gonna be VW all over VP. VW is what? 18. So it is gonna be times 100%, right? Times 100%. So VW is what? 18 meter cube. Then VP is what? 144 meter cube. Right? Times 100%. Okay? So that will be 18 over 144 times 100%. So that will be 12.5%. Okay, that will be 12.5%. Okay, so this is the what we are going to arrive at. That's the 12.5%. So that's the A part of the question. Okay, now let's go to the B part of the question. So the B part of the question says, at what rate is the water level rising? Okay. So let us erase this and come back to the water level. At what rate is the water level rising? Okay, so the B part of the question says, at what rate is the water level rising? So which means while the water is being pumped into the pool, the water will be rising. Let's say this is B, right? That's B. That's the depth, the deep part of the pool. And okay, so we have the volume. The volume of the pool is what? The volume of the pool. That's what? Area of trapezium. That is area of this entire trapezium. Half A plus B times height. So let's label these ones. This is A, right? So that's A. This is B, right? And then this is the height. We call this one H. This is H. Okay? Half A plus B times height. Then we call this one D, which is the depth. Okay? Or the width. Okay, now this one as it is now, the only variable here in this particular equation, that is the one that will be rising, is this B, right? Others are constants. This H is constant from here to here, it does not change. The depth is constant, it does not change. A is constant, does not change. So to fill up this, the only thing that will be rising is what? Is this B, right? That is, the water level initially will be at 0 here, and then it will, as the water is being pumped, it will be increasing until it's filled up, right? Which means the variable here is B, right? Okay, but we are going to differentiate this with respect to what? With respect to time. So with respect to time, this is going to be the VP, the T. It's going to be what? Half into d dt A plus B HD, right? Okay, so from here now, what is the differentiation of this one? This is the VDP, the VP dt is going to be 1 all over 2. Now ddt of this one is going to be these guys and these guys, they are constants, so that will be H, D, they will all be outside, right? D, the B of A plus B, right? Then the B, the T. They are applying chain rule here, chain rule. You know, if you strike this one, this out, this will still be preserved. So you're applying chain rule there. Because you are differentiating with respect to B. B is the only variable here. Okay? So that will be 1 all over 2 H HD. Now DDB of this one is going to be what? when you differentiate dB of A, you know, differential of a constant is 0, differential of B is 1. Okay, the B, the T. Okay, that's what we'll be left with. Okay, now the VDT is this now. So what is now the BDT? Because that is what we are asked to find in the question. At what rate is the water level rising? So the BDT is what we're asked to find. So from here, if you cross multiply, the BDT is going to be this one. These two will go and multiply this. That will be 2. Then this one will come under H and D, right? Then the VDT. Okay? So you use this one to multiply the VDT, then you bring these ones under it. You divide both sides by H and D, right? So what is the value of H and what is the value of D? So we'll put everything there. And what is the VDT? The VDT is given as 1 all over 4, right? So we put all those values there. 2 over H is what? 12. D is what? 6. And then the VDT is 1 over 4. Right? Meter cube. Okay, let's forget about it. We'll put the units later. Now 2 here 1, 2 here 2. Okay? So 6 times 2, 12. So that will be 1 all over 44. Right? Meter per second. Okay? 1 over 44 meter per second, because 2 times 6 times 2 is 12. 12 times 4, 12 is what? 144. So it's 1 over 4 meters per second. So this is the value of this is the rate at which this one is rising. Okay. So and that is the solution. Okay. Thank you.